The following program was produced by an independent community producer. The opinions expressed do not necessarily reflect those of the QATV staff or board of directors. QATV, in compliance with FCC regulations, is prohibited from exercising control over the content of independent, member-produced public access programming.
Hi, I'm Kathy Hogan. This is Dave Jacobs. And this is Gateway to Science, Sports and Games. And this is an instructional video that we have designed for the South Shore Science Festival. And it's the part that I'm involved with is, as I said, Gateway to Science, Sports and Games. And it also gets into the science of sound and the science of light and science and stories. These are activities that we do at the Science Festival, and what we're going to do is show you how to use them. We're going to tell you first what the principles are that you're going to learn through these items, and then we'll demonstrate them later. Okay, the next group over there is a golf club, an adult-sized golf club, and a set of golf clubs for a child. We'll find out later what you can learn through those. With the golf club and the golf ball, you can learn something that is called the angle of attack, or angle of access, or angle of incidence, and the angle of reflection.
And then over here we have some fun tools that you could use. We have a set of plastic cups with a string and a set of tin cups with a string, and I think you know what those are for.
And something that we don't have there, unfortunately, is a wooden baseball bat. So if you put those two together, that'll give you some more clues about what's coming up.
Over here with our cup phones, which we all know what those are for, it's really a study or a basic study on vibration and how sound actually travels on.
Moving along to the golf clubs.
Yep, here we have our golf club here and our golf ball. This is about the idea of the angle of incidence and or attack and the angle of reflection. So if you think of a protractor, measures 180 degrees around the top, half of a protractor. Right. Whatever angle the ball hits something at, it should bounce off and come back at that same angle. So
equal and opposite.
Equal and opposite.
An important principle in physics.
Yeah.
Are we going to try to demonstrate that here?
Yeah.
If we will attempt it.
Attempt it.
Attempt. Okay. Okay. Now, there we go.
So what Kathy's going to do first is she's going to hit the ball straight at the
on.
wall, and it should come back at pretty much
straight
the
back.
same angle. So it should bounce back straight.
If I handle it right. So let's see. Well, it's pretty much.
Pretty good.
Yeah.
You might notice that the wall has this runner along the bottom that has this little lip on it. That's probably what's causing the ball to not come back at that angle.
It's not my my problem.
No.
Okay, so now I'm going to try to have it go in at an angle. And when you see the angle that it goes in, it will come back at the equal and opposite. Well,
that one's a little off.
That one was off, and you might be right. It might be this the way the wall is made. Try it one more time. That was better. That was better. Yeah. So this is very useful information if you know that you can predict when a soccer ball or a golf ball or whatever it is, hockey puck, hits the side at a certain angle. You can anticipate that it's going to come out at the equal and opposite.
Yeah, and it's really a good idea. A good way to think of it is I like to think as a pool table. It's a great example because you do use the sides of the pool table so frequently to help you get the ball in the pocket, depending upon which one you're trying to get to. And hockey too has the wall around the.
Yeah, right.
around the rink. So that's very useful.
And it actually also works in basketball too, although the hoop is round, and that's going to have some impact on it. But this, I understand, I'm not an expert in any of this, believe me, but from what I have read, you can anticipate that it should come out at an opposite angle.
Yeah. It's definitely gonna, normally, unless, like we said, there's always engineered effects that take place, like, i.e. this wall is not totally vertical, there's not a 90-degree angle right there.
And that's the way it is in science. You know, there are factors that you may not be able to control, or maybe you can control them. And so you do that. Okay, and that, just hold up the child's, that's a child's set of golf sticks and golf balls and tees, so that's for the children. But I found this one when I was looking for something the other day. I said,
A nice one.
use this on the program. Okay, so finally over there, we have string cup phones or string can phones. Now we're going to show you the right way and the wrong way to hold these. Now, an important thing to learn through these is vibration. And you can learn it right in your own body through your vocal cords or your voice box, or the scientific term is larynx. You put your fingers on your voice box, and if your fingers tickle when you're talking, that's your voice box vibrating. That's a vibration. Then the vibration travels through the air, through the string, along the string, and then it goes to your friend's eardrum, which vibrates. Isn't that amazing? You can learn so much about vibration just through this easy, fun game. And so let's demonstrate with the can phones first and show them how not to do it.
Oh.
Okay? This is a very long string, and we can't demonstrate it here for you, but we can use this to demonstrate what not to do. And that is, do not let the string hang like that. Don't let it sag.
Nice.
So if you're speaking and it's not going to do anything, it's all that energy from your voice, from your vibration is going to get wasted.
I think it's a dropped call.
I think
it's a
that's
drop
right.
We got a drop call there.
Okay. Now, but with this one, this is a short string, and we can demonstrate for you what to do. Oh, I can't.
Oh, it's stuff on the
Here
line.
we go. Hello there, Dave. Can you hear me?
Yes, I can.
Oh.
Can you hear me?
No, I can't hear you.
No?
So this is an important thing to remember. Make sure that the string is tight, and the word is taut, T-A-U-T. Make sure the string is taut. A lot of times at the science festival, I see people doing it, and they're sagging like that. So you want to remind them, keep it taut.
And the interesting thing is, we had a conversation about this yesterday, is, when you talk and your vibration, your voice vibrates along this string,
Yeah.
that's called an analog wave.
Right.
And that's something that, we think like, oh, we talk into our cell phones, we talk into our phones, like our voice is being transmitted in an analog wave. But really what's happening is, if you hold this cup, when we talk into things like this, what happens is there's a transmitter in your phone, and it's actually turning your voice into a digital wave. It's actually turning it into light. And so in the ground, across the oceans and all that stuff, even cell phones work this way. It turns into a fiber optic network, and these fiber optic cables underground submit flashes of light that look kind of like Morse code, I guess, and it sends it out. And when it gets to where it's going to go, there's a receiver on the other end, and the digital code is turned back into an analog code, and that's the sound that you're hearing
That
at
is
the end.
amazing.
So even this technology, years ago, like, we used to use radio waves, and that was, analog waves in the sky, but now we've even gone back to just doing digital, but using light instead
And that's
of
where
actual taps.
the optic and fiber optic comes from, the
Yep.
light.
Mm-hmm.
Wow.
All light, yeah.
Amazing.
And that's why they say that things travel at this, voices travel at the speed of light. So,
Right. Wow.
but only through digital waves.
Well, actually, going back to when we don't have the baseball bat to demonstrate, but the point that we wanted to make about the baseball bat and the string can phone vibrations is that the sweet spot in the baseball bat is the place that has the smallest amount of vibration in it, or no vibration, and the energy of the ball hitting the bat just stays as energy and makes the ball go much further, and it doesn't go into your arm.
Right.
And you were telling me about that.
As we all know, anyone's ever played baseball, when you hit the ball, you tip it kind of at the end, it sends a vibration down your arm, similar to that of hitting your funny bone.
Yeah.
Nothing funny about that, right?
No, nothing funny about that. So I bet you didn't know that that was physics, and it is. And that's what this is all about, is to help you realize that through the things that you like to do for fun, you understand physics. And your body understands physics. Your body understands all these different things. And what we're doing is helping you to learn it from experience, hands-on activities, and through vocabulary. The language part of it is important in forming concepts. It takes it away from just being a physical sensation, a pleasant or an unpleasant one. And you learn what the physics force is, and you're learning science this way too,
And so
through what you love.